Ever pondered the route taken by EVs from point A to point B? Is it just an internal combustion car that is connected to a massive battery, or are there other, more cunning tricks at play? Today, when we look under the hood and inquire as to how exactly electric engines operate, we discover, surprise, that the most modern electric vehicles operate on a principle that was developed decades before the internal combustion engine. Sabrander Strating, a Dutch professor from Groningen, developed his own miniature electric car in 1834 using an internal combustion engine and a non-rechargeable battery. The idea behind how engines operate is that when fuel and air are compressed and ignited, a small explosion results. The combustion component is that when a piston is pushed by an explosive force, its linear motion, combined with the action of a group of other pistons, is converted into rotating motion by a mechanical crankshaft. Your wheels are then spun along the roadway. Nevertheless, electric cars are powered by magnets, according to their basic operating principle. Everyone is familiar with how a magnet's opposing poles attract and repel one another. So let's envision a test with two magnets. Both were fixed by the first. The magnet, which is installed on a nearby rotating shaft, will be repelled since it is attached if the two poles on both magnets that are closest to one another have the same polarity, say north to north. In our hypothetical experiment, if we apply a shaft, the shaft will rotate until the south pole on the shaft magnet is lined up with the north pole on the fixed magnet, at which point the shaft will become still once more. While turning the shaft by half is great, it won't get us very far on the morning commute. This is when electromagnetism, in the form of a fixed or permanent magnet, comes into action. Those magnetic poles are fixed and unchanging, much like the ones on your refrigerator at home. North is and always will be. However, south is always south on an electromagnet, which is essentially a metal core with electrical cables wound around it. It is possible to change the magnetic polarity. Think of one of if the south pole of our experimental magnet swiftly switches from north to south, it becomes an electromagnet. Once more, the fixed magnet will reject the moving magnet, causing our shaft to rotate by half a turn. If we remove the battery from the circuit, turn it 180 degrees, and then put it back, these electrons will continue to go in the opposite direction around the circuit. The polarity of the magnet is reversed with the flow of electrons, which is an ingenious way that electromagnets, like light bulbs, work in whichever direction the electrons are flowing. Therefore, to keep our magnets in permanent repel mode, we just need to keep reversing the polarity of the magnet. How do we go about doing that? One method would be to repeatedly pop out the battery and turn it. But for the sake of a few feet of ground, that's a lot of trips to the mechanic in your EV. Covered. So to make a magnet spin, which is essentially how electric motors operate, the true secret is accomplished by the inverter. Domestic electric motors like the one in your hairdryer don't need an inverter because the current that comes from your wall outlet already flips back and forth, which is why it's called alternating current. AC batteries of various sizes, and the inverter module on the EV draws direct current from the car battery. With the help of a clever combination of quick switches, slick circuitry, and capacitors, flip the flow of electrons back and forth nearly 60 times a second. For begin, there are several benefits of electric powertrains over internal combustion engines. In contrast to dirty pistons on an ice surface, which need a complex, breakable crankshaft only to convert their linear motion into rotational motion, the motion generated by the motor is already rotating in nature. Consequently, EVs are less likely to malfunction or need costly, time-consuming repair. Another ingenious feature of that inverter is that the driver may ultimately tune the vehicle's speed and torque by varying the frequency and amplitude of the freshly produced waves. An explosively hot internal combustion engine is expensive because it lacks such fine control. And cumbersome additions like gearboxes are prone to accidents. Another interesting aspect of any the EV's powertrain is engaged when the shaft-mounted magnet, or rotor in technical jargon, is rotated. It produces electrical energy. The automotive battery can be simply recharged by this reversal. You ask that the rotor be spun using any sizable kinetic energy source, such a car in motion. It is useful. This is a very basic summary of the various kinds of electric motors, just to be clear. Innovative design improvements are continuously being made, not least at one particular Californian automaker named after the brilliant man who independently discovered the magic of alternating current in the 19th century. Thanks for watching. Like, share and subscribe.